Hello algebra students, this is Mr. Montes again. I am so sorry for having to make two videos. This one is the second part to PHS Laws of Exponents Lesson 1. This one will be called PHS Laws of Exponents Lesson 1 Examples, since I didn't get to get into those in the last video. Just to recap everything that we just went over in the last video, is we went over this thing called product of powers, which basically says that if I have a base to a power multiplied by the same base to a different power, we can add those two together, and we have an example right here. 3 to the power 2 times 3 to the power 7 is equal to 3 to the power of 2 plus 7, which is 3 to the power of 9. We also had the power of a power rule, which stated that if I have a to the m power and I raise that to the nth power, we can just multiply those two powers together. Here's an example on the right. We have 5 to the power of 2 to the power of 4. That's equal to 5 to the power of 2 times 4, which is equal to 5 to the power of 8. All right, we have another one right here. This was the distributive property for the exponents. If I have two bases, they don't have to be the same, and I have raised that to the power of m, I can just multiply those exponents together. So, for example, over here I have 2 times 3. That's the same thing as 2 to the power 6 times 3 to the power 6. Now, I'm actually going to give you guys one more example on this one, just because this doesn't fully show what's happening. But if I had 2 to the power of let's call that 4 times 3 to the power of 2, and I raise that to the power of 5, this distributive property for exponents allows me to multiply the 5 to the 4 and the 2 to get, whoops, sorry about that, hold on, let me go back, to get 2 to the power of 20, which is 4 times 5, times 3 to the power of 10, which is 2 times 5. So I can rewrite it like that. In this case up here, we just had to think of this as having a 1 there and a 1 there. 6 times 1 is 2 to the power of 6. 6 times 1 here is 3 to the power of 6. All right, so that's just a quick recap of what we just did. Let's get into some examples here. We have here 5 to the power of 3 times 5 to the power of 6. So here I can use that first property, which says that I can just add the exponents because I have the same base. And I should do this in a different color. I have the same base and I'm multiplying. So I just put down 5, and this will be to the power of 3 plus 6, which is equal to the power 5 to the power of 9. So I just add those two together. All right. Another example. This time we have 3 of them. They have the same base. I'm still multiplying, so I'm still okay. So I'm still able to use the product of powers. The only difference is I have 3. So how do I deal with that? Well, the same way. X is my base, and that's going to be raised to the power of 2 plus 3 plus 4, which is equal to x to the power of 2 plus 3 is 5. 5 plus 4 is going to be 9. Perfect. Now what about this one? I have the same base. I'm still multiplying. That's okay. I'm always going to check that. So I have 3 to the power of, wait a minute, this has no exponent, but it does, put a 1 right there, 3 to the power of 1 plus 5, which is equal to 3 to the power of 6. All right. Now, again, we should note that we have multiplication between these two pieces here, these two parts, two expressions, and we have the same base for every single one. That is why we're able to use the product of powers rule. Now here's something a little bit different. Okay, I have negative 2 in parentheses. That's to the power of 1. And negative 2 in parentheses here to the power of 4. I'm going to treat it exactly the same way. I have negative 2 as my base, the entire thing, and I must keep it in parentheses. Negative 2 in parentheses. And this is going to be to the power of 1 plus 4, which is equal to negative 2 in parentheses to the power of 5. Now, why the parentheses? Well, here's a quick reason why. It has to do with the order of operations. Let me put a line there. If I wrote negative 2 to the power of 5, what's really happening here on this negative 2, I'm actually multiplying negative 1 times 2 and then raising it to the power of 5. Now, the order of operations says that we need to do exponents first and then multiplication. So what would happen here is I would end up with negative, and maybe this is a bad example. Let's use 4. I would end up with negative 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. I'd end up with negative 16 here. And again, it has to do with the order of operations. I got to take 2 to the 4th power, and then I multiply it by a negative 1, which would give me negative 16. Versus if I had negative 2 in parentheses and I raise that to the 4th power, what this is saying is that I have the base negative 2 multiplied to itself 3 times. So I would have negative 2 times negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2 would be positive 4. Positive 4 times the negative 2 would be negative 8. The negative 8 times the negative 2 would be positive 16. So I actually end up with 2 different results here. So that's why the parentheses are very, very important here. There's actually more to that. There's some more stuff that I could do. But again, this is just a quick example so that you understand where that comes from. Just keep in mind that the parentheses need to be present there. So let's do some handful of more examples here. Looks like we have a power to a power rule here now. Now remember, our base is negative 3. We have parentheses, so let's keep the parentheses. So I will have this. This will be negative 3 in parentheses to the power of 3. Now, when we have a power to a power, we multiply those two exponents. So this will be negative 3 in parentheses to the power of 3 times 2, which is negative 3 to the power of 6. Now, do I simplify that? I mean, you can, but this is such a big number. I'd rather you all just leave it as negative 3 quantity to the power of 6. Let's do another example here. I got this one. I got 6 times 5. Now I'm going to put a little parenthesis, a little 1 right there, a little 1 right there. Now I know I could take 6 times 5 to get 30 and then write it as 30 to the power of 2. I actually want you all to use the properties and practice using these properties. I know there's other ways that we could do it, but we just want you all to practice this for a bit. Later on, we'll be able to choose whatever way we really want to write it in. So this would be a power to a power, plus I'm doing this little distributive property thing. So this would be 2 times 1 and 2 times 1. So I'd have 6 to the power of 2 times 6 to the power of, 5 to the power of 2. And in this case, that there, I can just leave it like that. No big deal. If you really want to calculate it out, that's fine. Just make sure you take this intermediate step. This is really what we're looking for, the application of these properties that we showed you earlier. Next example. I got quantity, and then quantity again, a plus 1 to the power of 2, and then that's all raised to the power of 5. This looks confusing, but I am going to think of that thing in parentheses as one thing. I'm raising that thing to the power of 2. I'm going to use my property just like I would before. I'm going to write this as quantity a plus 1 to the power of 2. Now when we have a power to a power, we just multiply times 5. Now this will give you a plus 1 to the power of 10. Now I urge you to not do this. This part, I'll write it in I'm already writing in red, I'll write in blue. A plus 1 to the power of 10, we cannot do this distribution here that kids want to do typically. We don't have multiplication, so that distributive property for exponents does not work in this case. This does not equal a to the power of 10 plus 1 to the power of 10. That does not work. So once you get to this point, once you get to that point, just leave it. You're done. There's actually some stuff that we're going to do in the future that's where we're going to show you how to multiply stuff like this out. And we just probably not to the power of 10. This gets really messy, but in this case, just use that property. Think of that thing in parentheses as just that quantity, and then just leave it. All right. So next one, we have 4yz quantity to the power of 3. I'm going to write a little 1 above each piece right here. And I have a power to a power plus that distributive property for exponents here. So I'm going to take the 3, multiply it to 1, that one right there, and that one right there. So this turns into 4 to the power of 3 times y to the power of 3 times z to the power of 3. Now notice I didn't write multiplication in between them. I don't have to. I can put it there if I want to. But again, it's not a big deal. Actually, I prefer it without, just because it makes it a little less messy. In this case, if you wanted to, you could rewrite this 4 to the power of 3 as 4 times 4 is 16, times 4 is 64, as 64 to the power 64 times y to the power of 3, z to the power of 3. Either one would work. If you want to leave it like this, perfect. If you want to leave it like this, that's also fine. Again, here the property that we're using is that distributive property for exponents. All right, one more example. And this one is a multi-parter. We have several things that we're dealing with. We got quantity to the power of 3, so we're going to use that distributive property. So let me go ahead and put those ones where I need them, on that y and on that 4. And then after we do that, we're multiplying by x to the power of 5. So let's just start. We have 4 to the power of 1, multiply it to that, and that. So this will be 4 to the power of 3. X to the power of 3 times 2, which is 6. And then we have y to the power of 3. And then we have times x to the power of 5. Now, what we need to notice here is I got x to the power of 6 and x to the power of 5, and I have multiplication separating all those pieces there. So what I'm going to do is I'm going to rearrange this. I'm going to rewrite this as 4 to the 3rd, x to the 6th times x to the 5th, and y to the 3rd. All multiplication between those. I'll put those in. I know I said I didn't care for them earlier, but let's put them in for fun. So in this case, what I can do is I can actually use a specific property with that. I can use the product of powers. So I'm going to rewrite this again as 4 to the power of 3 times x to the power of 6 plus 5 times y to the power of 3. And I'm going to finish this up as 4 to the 3rd, x to the 11th, and y to the 3rd. And I'm done. Again, you could rewrite 4 to the 3rd as 64, x to the 11th, y to the 3rd. At this point, we're not really concerned about that. Either or would work. All right. If you didn't quite catch that, feel free to rewind the video and watch it step by step. Again, we're just using those 3 properties. This last problem is a little bit more difficult because we're using multiple properties on one problem, one expression to simplify it. But that's pretty much it. Now, what you all are going to get, let me see if I can pull this over, is this worksheet has got some problems. If you guys have concerns or you can't do some of the problems and you have questions, feel free to email us and let us know, and we'll help you. All right. Stay safe and have a good day.